Hello everyone, this is your instructor, Engineer Muhammad Salman Kiyom, and it's the 7th lecture of Solar Engineering and Designing course. Today we will discuss the important data about the solar panels, how the data is collected, how it will be used in the solar system calculations. First of all, for the data collection, we need to have a solar panels datasheet. This datasheet will be provided by the solar panel manufacturer. It can be taken from their website or directly from the company or from the distributor from where you are getting the solar modules. In this lecture, I will discuss the two solar panels. The first one is monofacial solar panel. The second one is bifacial solar panel. For the discussion, I have taken the datasheets from the JA solar manufacturer. And the first one for the monofacial solar panels, the model number is JAM72 F30 525 to 550 MR. And the series is Deep Blue 3.0 series. In this solar panel datasheet, we can see the company has used the 11 bus bar per cell technology, and the configuration in which the solar cells are assembled is the half cut. Due to this configuration and technology, now the energy performance is much better as compared to the previous technology. Now they are performing better in the low radiance area, shading areas. Now they have the lower risk of generating hotspot. They have the great mechanical bearing capacity. In the datasheet, we can see that they have provided the graph for performance warranty. They have compared their latest 11 busbar per cells technology with the standard solar cells technology. They are getting the better performance till the 25th year. Now we can see from the graph the annual degradation for the first year for this solar panel is 2.0%, whereas for the standard cells, the solar annual degradation for the first year is 2.5% to 3%. We can also see that the annual degradation for the further years to 25 years is 0.55%, whereas for the standard solar cells, the annual degradation is 0.7%, which means that this particular solar panel will produce the more power in every year as compared to the previously standard solar cells technology. In the datasheet, we can see that they have provided the mechanical specification of this PV module. For this PV module, they have used the number of cells 144. The cells technology is monopile technology. The weight of the solar panel is 28.5 kg. The length of the solar panel is 2.279 meter, whereas the width is 1.134 meter, whereas the depth of this frame is 35 mm. The cable that they have provided with this solar panel is 4 mm. The length of the cable varies according to our requirement. Sometimes our requirement is for just 300 mm, and sometimes we need up to 1.3 meter. So the connectors with the solar panels comes in MC4 type and QC4 type. Also, we can see that they have given the back side of this solar panel frame where we can install our bolt, what bolt size we need to use for the mounting racks, and where we can install our earthing cable. All of the things, all of the description is provided in this image. Every solar company that is producing or manufacturing the solar cells and solar panels must have the following certification: the IEC 61215, the IEC 61730, whereas the company internal system should qualify with the QMS quality management system, ISO 9001 certificate, the environmental protection systems certification like the 14001 certificate, in addition with the occupational health and safety certification like the 45001. These are the mandatory certifications, otherwise that solar panels will not be in the tier 1 category. Now we are going to discuss very important data which is to be noted from the solar panel datasheet and going to be used in the solar system calculation. First of all, I have chosen the 550 watt solar panel, and this power will be the maximum generation from the solar panel. This generation will only happen when it meets the certain conditions, standard temperature conditions, and it is when the solar radiance from the sun coming on per meter square area is 1000 watt, and the incident angle modified in the space is 1.5 G, and the temperature of the solar cell is 25 degrees centigrade. Only on that condition the solar panel will generate the maximum power of 550 watt. The VOC, VMP, IAC, and IMP are the parameters of voltage and current. VOC generally denotes the open circuit voltage, and VMP is when the strings are formulated and connected with the inverter and loads are applied on the inverter and system is running. Then the voltage produced by the solar panel is the VMP maximum voltage. And same for the current, when the circuit is short, when the leads are connected only with one solar panel, the maximum solar current at zero resistance will be the short circuit current, and it is around 14 amps. And we can see from the datasheet the open circuit voltage is around 49.9 volt, and the VMP voltage when the panels will be connected and strings will be formed 41.9 volt. The short circuit current is around 14 amps, and the IMP will be around 13 amps. When these FTC conditions will meet and all of the parameters which are displayed in the datasheets occurs, the efficiency of the solar panel will be 21.1%. This means that all of the energy coming on the solar panels will be converted at the rate of 21.1% into the efficient solar output. The temperature coefficients are for the current, voltage, and power. When 1 degree temperature change happens, the current will be changed by 0.05% per degree centigrade. The voltage, VOC, open circuit voltage, will be changed by 0.275% per degree centigrade. The power will be changed by 0.35% per degree centigrade. These signs are very important. You don't need to forget them. These will be used in the calculations. Also, the maximum voltage for interconnection to make the maximum string length will be the 1500 voltage. NOCT values means that now the solar panel is connected on the atmosphere, and the radiance coming from the sun is generally around 800 watt per meter square. The angle modified will be the same. Instead of considering the cell temperature, we consider the ambient temperature, which is 20 degrees centigrade, and the wind speed, which is around 1 meter per second. At this temperature condition, our solar panel will reduce the power. The power will be around, instead of 550 watt, 416 watt. Okay. At these conditions, when the sun radiance is 800 watt per meter square, angle modifier is 1.5, the wind velocity is 1 meter per second, and ambient temperature instead of cell temperature is 20 degrees centigrade, our solar panel will produce 416 watts energy instead of producing 550 watt. Okay, you get it. Now the voltage parameters and current parameters will also change. This effect will be due to these temperature coefficients of the solar cells. Now, the VOC of this solar panel at NOCT values will be 46.68, VMP will be 39.43 voltage, and ISC will be 11.17, and the IMP will be 10.55. Why this happens? This happens due to these temperature coefficients of current, voltage, and power. So due to this effect, at NOCT values, our solar panel will not produce 550 watt, instead it will produce 416. The important thing is that if we get low radiance 500 watt per meter square or 600 200 per meter square, our voltage will be more dropped because the sun energy will be lower. The temperature coefficient will be different for the power as well as for voltage and every parameter. So we see that the NOCT values and the STC values are different, and NOCT values are in the result of all of these parameters. Generally, STC conditions are when we manufacture the solar cells and we test it in this particular condition in a laboratory, our solar cells as a combined will provide 550 watt. If in the atmosphere all of this happens, STC condition happens, our solar panels on the solar panel level will provide 550 watt. Otherwise, whether the temperature is 35 degrees centigrade or minus 5 degrees centigrade, the effect will be in our reflect in our energy output. The datasheet provides the graphs about the current, voltage and power, the current versus voltage with respect to the radiance coming from the sun, power versus voltage with respect to the radiance coming from the sun, the current versus voltage with respect to the ambient temperature. Let's discuss the current versus voltage curve with respect to the radiance coming from the sun. When the radiance is low, like in this case 200 watt per meter square, the voltage is nearly equal to 40, and the amps generated from the panels will be around 2 point something amps. And when the radiance getting high and up to the 1000 watt per meter square, the maximum voltage will be 49.9 volt, and the maximum current will be around 13 point something or 14 amperes. Now consider the second case, which is the power versus voltage with respect to the sun irradiance. In this graph, we can see when the irradiance level is higher, 1000 watt per meter square, and the voltage is nearly equal to 49.9, the power curve reaches the maximum power, which will be 555 watt. When the radiance is lower, the voltage will be lower, the power in result will be lower. In this case, for the 200 watt per meter square, we can see that the graph is nearly touching the 100 watt when the radiance is 200 watt per meter square, and the voltage is nearly equal to the 47, 48. This is due to the effect of all of these coefficients. Now, consider the third case, the current versus voltage with respect to the temperature, ambient temperature. We can see that when the temperature is lower, nearly equal to minus 5 degrees centigrade, the voltage will be very high. It will cross from 49.9 volt to something between 53 volt. But the current will be lower. Okay. The maximum current we will get at 25 degrees centigrade, voltage will be 49.9 and the current will be 14 amps. When the temperature will be maximum to 70 degrees centigrade, the voltage will be lower, the current will be lower. Current will affect by minor percentage of a degree centigrade, like 0.045 percentage per degree centigrade. But the voltage, as the temperature gets lower to nearly minus 5, the voltage will be rise to around 53. In the last, we can see that the maximum string voltage is 1500 volt. The maximum front side bearing load bearing capacity is 3600 static load Pascal, and from the back side is nearly equal to 1600 Pascal load bearing capacity. And we can also see that the NOC temperature is nearly equal to 45 degrees centigrade, plus minus 2 degrees centigrade variation can be happen. And the safety class is 2 and the for protection class is UL type 1. In the next lecture, we will discuss the solar panel datasheet about the bifacial PV module, because that datasheet will have some more parameters to be considered during the solar panel sizing. So that will be discussed in the next lecture, which will be the lecture number 8. And we will discover all of the bifaciality factors, the bifaciality gain, how much power we can increase from the rear side of the solar panels. So that will be discussed in the lecture number 8. Thank you very much.